The railroad industry has undoubtedly been one of the most fundamental pillars behind the enormous economic growth and development of the United States, dating back to its early years in the 19th century. The creation of an extensive railway network that connected the entire country went hand in hand with the development of powerful machines capable of moving tens of tons across the vast expanse of the nation. During an era when steam engines were widely used, the rise of massive locomotives led railway companies to constantly seek stronger and more powerful equipment, giving birth to some of the largest mechanical monsters in history. As such, the railroad industry in the United States was born with the construction of the first coal railroads in 1827, followed by the first commercial passenger railroad in 1830. Around that same time, the first railway link connecting Baltimore with Ohio was established, laying the foundation for common freight transport. By the 1850s, train lines had already expanded considerably, as the eastern half of the country was now connected by an extensive railway network. However, what truly marked a before and after for this industry was the emergence of one of the largest and oldest railway companies in the United States, Union Pacific. Created under the newly established Pacific Railroad Act, signed in 1862 by President Abraham Lincoln. The purpose of this act was to connect the Western territories with the rest of the country's vast infrastructure, which was finally completed in 1869, with the joining of the Union Pacific and Central Pacific lines in Utah. From that moment on, with major cities connected through steam trains, the infrastructure continued to expand exponentially, reaching nearly 400,000 kilometers, or more than 250,000 miles, by the early 1940s. However, due to the massive flow of freight, Union Pacific began to depend on increasingly powerful solutions, leading them to experiment with truly enormous and impressive steam locomotives. One of the most important incursions that Union Pacific had into this type of large machinery were the ones known as Challengers. These were articulated steam locomotives with a 4-6-6-4 distribution, which were developed and manufactured with the help of the American Locomotive Company. A total of 105 units of different classes were produced from 1936 to 1944. These locomotives proved to be quite useful for complicated routes, mostly mobilizing cargo of up to 3,200 tons. This was mainly because it was possible to implement in their designs some unique features of passenger trains, thanks to which they were capable of exceeding 100 kilometers per hour in speed and overcoming considerable slopes at full load. However, upon entering one of the main lines of the railway company, which crossed the Wasatch Mountain Range between Green River and Ogden, all models had problems supporting the prolonged slopes. The incline remained at 0.8% for most of the route, reaching a maximum of up to 1.14% continuously. When towing a load of more than 3,200 tons, they were forced to use auxiliary locomotives, slowing down operations due to how complicated it was to add and remove this support equipment. As the routes from eastern Utah to western Wyoming became complicated, Union Pacific, again in collaboration with the American Locomotive Company, led a project to design a new locomotive based on the original designs of the Challenger. By lengthening the boiler and adding more drive wheels, the protagonists of our story were born, the big boy locomotives. At 40.5 meters long, 3.3 meters wide, and almost 5 meters high, these locomotives, weighing almost 250 tons, were truly unique. No other steam locomotive managed to have a similar arrangement to the big boy's 4884 axles, which were distributed in 2 sets of 8 drive wheels, along with a 4-wheel guiding bogie at the front to provide stability on curves, and a second 4-wheel bogie at the rear to support the large-sized firebox. A total of 25 of these locomotives were produced, built in 2 batches of 10 and a final batch of 5. Classified as Class 4000 equipment, these enormous machines aimed to stably exceed 130 kilometers per hour, as this way it would be possible to overcome the Wasatch Mountains route without external help. It goes without saying that they succeeded, and quite easily, since by the late 1950s, tests were conducted showing they could complete this route without setbacks, even pulling 4,000 tons. The big boy locomotives proved to be the ideal solution because they could generate an estimated power of around 6,300 horsepower, even though they burned low-quality coal from the Wyoming mines. Curiously, an experiment was attempted with locomotive number 4005 by installing fuel burners. Unfortunately, Contrary to what happened with the same experiment on Challenger models, this change was not successful at all, so the Big Boy was converted back to coal. The reason was that the heat was insufficient and uneven. Although initially the Big Boy locomotives only covered the Utah routes, while the Challenger maintained operation on the rest of the important tracks, these gigantic machines provided an extremely important service at the height of World War II. The reason was that they were designed to be easy to operate, even for beginners. This was crucial since it was necessary to work with operators exempted from military service, many of whom had little or no experience in this industry. Curiously, during the war, German agents reported on the enormous steam locomotives that could tow huge trains packed with vital war materials through the mountains at high speed. However, these reports were dismissed, labeled as not credible or impossible, when in reality their performance was essential to move enormous quantities of materials that made a huge contribution to the war effort. It should be noted that the Big Boy was not actually the largest locomotive in terms of weight, length, power, and traction, as there were others that surpassed it in some of those particular aspects. However, in terms of overall performance and reliability, what the Big Boy achieved was simply insurmountable. Ironically, the very end of World War II was the trigger for this type of locomotive to slowly begin to leave the tracks. A new wave of labor, along with the steep increase in the price of coal and the appearance of much more efficient propulsion systems, such as diesel, electric, and gas turbines, were responsible for announcing the limited lifespan of the Big Boy. Even so, these were some of the last steam locomotives to leave service, as the last train hauled by a Big Boy was towed in 1959, ceasing operation on the morning of July 21st. Due to the legacy they have left in the development of the United States throughout past centuries, the Big Boy locomotives are among the most representative and best preserved steam engines ever built. Of the 25 originally manufactured, 8 are still preserved today, distributed among the states of Wyoming, Colorado, Missouri, Pennsylvania, Nebraska, Texas, and California. Of all these preserved locomotives, the one marked with the number 4014 was reacquired by Union Pacific in 2013 in order to put it back into operation. For this, it was necessary to move it to Cheyenne, Wyoming, where it underwent a complete restoration process for several years. Finally, in 2019, this gigantic machine was able to return to the glory of its heavy-duty days after an enormous challenge in which engineers needed to acquire parts that took years to find, as well as manufacture many others from scratch, using the old blueprints and forging them through computer-aided design. Thanks to this work, the Big Boy 4014 has become the largest and most powerful operational steam locomotive in the world, ironically taking this title from the Challenger 3958, which was also restored years ago. However, far from the competition between these colossal machines, both perfectly represent the legacy of tireless effort, hard work, and determination that led the United States to become one of the world's greatest powers.